Good morning, everyone. Today we discuss the next point, differential amplifier and its types. In that topic, we introduce firstly about amplifier and operational amplifier, and then discuss the points, differential amplifier, types of differential amplifier, and difference between normal amplifier and differential amplifier. What is an amplifier? Amplifier is an electronic device which increases the power of input signal. Such amplifier split into the two types. First one is single stage amplifier and multi-stage amplifier. It is also known as operational amplifier or short form OPAM. In single stage amplifier, it uses single transistor so that the gain of the single stage amplifier is very low, and such a small gain or low gain is not sufficient for practical use. It is necessary to enhance the gain of the amplifier only when if two or more stages are coupled together. Such a multi-stage amplifier known as operational amplifier or linear integrated circuit has different advantages, like it is a direct couple amplifier. It has two inputs and one output, high gain, wide bandwidth, and it amplifies AC and DC signals. Nowadays, operational amplifiers are available in the form of the integrated circuits, and they have the advantages like very small in size. It eliminates the complex wiring, and the cost of the component is to be very low. Such a operational amplifiers are widely used in audio, video amplifiers, oscillators, and voltage regulators. If we connect the external components to its terminal, the characteristics of the circuit or the properties gets changed and it becomes used for the particular application. Differential amplifier is a basic stage of operational amplifier. Therefore, it acts as a direct coupled amplifier. Here the circuit connection for the typical differential amplifier is shown here. It uses the two balanced stages which amplifies the difference between the two input signals V1 and V2. That amplification is taken in between 0 to few megahertz. In that circuit connections, two symmetrical stages form emitter coupled differential amplifier, since the emitter of the one transistor T1 and emitter of the second transistor T2 is coupled together, and it form a emitter coupled differential amplifier. Here it shows the two inputs V1 and V2, and that inputs are connected to base of the transistor T1 and base of the transistor T2. RC1 and RC2 are the two collector resistance. The two identical amplifiers formed by RC1 transistor T1 and resistance RE. Similarly, the another stage, it also formed by RC2 transistor T2 and resistance RE. These two stages are connected in such a way to form the perfect symmetric emitter coupled amplifier. Here RE is the common emitter resistance. RC1, RC2 are the two identical resistors connected across the collector of the transistors. When V1 is equal to V2, means two input voltages are identical, output voltage becomes 0. Now we draw what is its symbol. The symbol of the differential amplifier is shown here. Here are the two inputs and we get one output V0. When V1 is greater than V2, then output voltage polarities is shown as like here. But if V1 is less than V2, then what happens? The output voltage gets inverted and it show opposite polarities. Such a differential amplifier has two separate inputs V1 and V2. V1 is called as non-inverting input because output voltage is in phase with V1. And if V2 is inverting input, then output voltage is out of phase with V1. It means it is 180 degree. In that case, the difference between the two input voltage is known and output voltage is known, then gain of the differential amplifier is output voltage divided by difference between two input voltages, that is V0 divided by V1 minus V2. It means when both non-inverting and inverting voltages, it form differential inputs because output voltage V0 we easily calculate from that relation and it is to be output voltage V0 is equal to difference between the two input voltage multiplied by voltage gain of the differential amplifier. Such a differential amplifier having four types that we discuss one by one. There are four types of differential amplifier. In that, the first one is double-ended input and double-ended output. In this type of amplifier, the two stages connected as it form emitter coupled differential amplifier. In this case, both inputs V1 and V2 are present simultaneously, and output is taken between the two collectors. Then what is the gain of this type of differential amplifier? It is given as output voltage divided by input V0 divided by V1 minus V2. The another type of differential amplifier is single-ended input and double-ended output. Its circuit connection is shown here. In this type of differential amplifier, it has one input, whether V1 or V2, V1 or V2, and output is taken between the two collectors. If one of the input is 0, whether V1 or V2, here V2 is 0, then output voltage we calculate as we know the gain of the differential amplifier. Therefore, firstly, what is gain of the differential amplifier? Output divided by input voltage. There is only single input. Therefore, V0 divided by V1 is the gain of this type of differential amplifier. Therefore, the output voltage V0 is equal to gain multiplied by V1 since one of the input voltage is 0. Such a double-ended output for has few applications because it requires floating loads and both ends of the loads are connected to collectors. This is another type of differential amplifier as double-ended input and single-ended output. It is represented as it has two inputs, but output is taken at one of the collector. Therefore, it is a single-ended output. Such a type of differential amplifier is most practical and widely used this type of differential amplifier has same gain as therefore the output voltage becomes equal to gain multiplied by V1 minus V2. And another form of the differential amplifier is single-ended input and output, means one input and one output. Its circuit connection is shown here. In this mode of operation of the differential amplifier, one of the two input is present, whether V1 or V2. If we say the V1 is present here and output is taken at one of the collector, in all these mode of the operation, the transistors T1, T2 are identical. Two resistances RC1, RC2 are also identical. VCC is the collector power supply and it is positive, whereas emitter voltage supply, that is negative, that is minus VEE, and RE is the emitter resistances. This type of amplifier is useful for direct coupled stage when only one input is to be amplified. Its gain is V0 equal to gain multiplied by V1 as one of the input voltage is 0, V2 is 0, then output is V0 equal to gain multiplied by V1. Now we distinguish between normal amplifier and differential amplifier. Now what are these differentiating point between these two amplifiers? Normal amplifier, it uses one transistor as we discussed earlier, and differential amplifier which uses the two transistors and it forms direct coupled amplifier. In this normal amplifier uses one input voltage while differential amplifier uses two input voltages. Next point is, in normal amplifier single voltage supply is used, while differential amplifier two supplies are used since two stages are there. Normal amplifier amplify only one input, while differential amplifier amplifies two inputs. Output voltage is taken between collector and ground. Here output voltage is taken between the two collectors of the two stages. Input voltage for the normal amplifier is in between base and ground, while for differential amplifier it is in between the two bases. As we discussed earlier, normal amplifier or the ordinary amplifier has low gain and it is not practically useful. Such a gain is up to 100 only. To enhance the higher gain, we use differential amplifier. Therefore, the gain of differential amplifier is very high and it is up to 1000. Frequency response is in terms of kilohertz. In differential amplifier, frequency response is very high. It is in terms of megahertz. We know normal amplifier which amplifies the small signals and it measured in microvolt. It also amplifies very small signal. It is in terms of the microvolt. Normal amplifier noise signal is also amplified, but differential amplifier there are two stages coupled together, noise completely eliminated. And last one is normal amplifier gives inferior impedance, while differential amplifier it gives the superior impedance. Now these are the various distinguishing points between normal amplifier and differential amplifier. The next point we continue in the next lecture. Thank you.